This video talks about how to implement an f-test that was first proposed by Engle 1982 to detect arch effects in residuals. It's also called a Lagrange multiplier test of Engle 1982. Now that f-test of Engle 1982 for detecting arch effects in residuals works as follows. Now, as expected for an f-test, you have to specify for how many legs you would like to test for autocorrelation. Let's call that leg length m, and let's say that m is equal or larger than 1. Now, first, you're going to regress the time series of squared residuals onto its m legs. Mathematically, it means you estimate the following regression. Note here that the E stands for the respective residual at time t. Now second, your H0 hypothesis is that there is no statistical evidence for an autocorrelation in the squared residuals. So the respective H0 hypothesis is therefore the following. The alternative hypothesis is that there is sufficient statistical evidence for autocorrelation for at least some of the legs. So conceptually, we can write the alternative hypothesis as follows. Now third, you compute the test statistic with the empirical data that you have. Now the corresponding test statistic is called f of m, and it's determined by the following expressions here. Note that the E hat is the least squares residual of the prior regression. So when you look at that test statistic f of m, you will notice that it checks whether a m-leg structure in squared residuals is helpful to explain variations in squared residuals. Now fourth, if the H0 hypothesis was correct, then f of m would follow a chi-square distribution with m degrees of freedom. We denote such a distribution as follows. Therefore, let's say you want 95% certainty, so you would choose a 95% significance level and a 5% type 1 error probability. In that case, you reject H0 if the realized value for f of m is larger than the 95th percentile of chi-square of m. Now we can formalize that as follows. Let alpha be element 0, 1, standing for the magnitude of the type 1 error. And let 100 times 1 minus alpha be the respective confidence level. You reject H0 at a 100 times 1 minus alpha confidence level if the realized f of m is larger than the 100 times 1 minus alpha percentile of the chi-square distribution with m degrees of freedom. Otherwise, you fail to reject H0. So the decision rule is equivalent to rejecting H0 if the respective p-value is smaller than alpha.
Got feedback? We would love to hear it. Please drop us a line. And if you liked the video, give it a thumbs up. And don't forget to subscribe to the channel.